Good morning, students. Chapter 7, Alternating Current. We have completed all theories and all illustrations and examples and exercise. Now we will see some extra questions. See, here it is. Prove that the average value of an AC voltage V is equal to Vm sin omega t is 2 Vm upon pi over half period of each cycle. See, you know how to find average. What is equation to find average? Here it is. Average of V is equal to average of Vm sin omega t. Okay? Yes. How to find average over half period of its cycle? Yes. Equation is 1 upon t by 2 integration 0 to t by 2 Vm sin omega t. 1 upon t by 2 because we have to find average over half period of its cycle. Limit is also from 0 to t by 2 and this function, its integration, which is back to time. Okay, Vm, maximum value of voltage, it is constant, so it is out of integration, is equal to this 2. I can write in numerator, so it is 2 Vm upon t. Here it is integration 0 to t by 2 sin omega t. Okay, now we know that what is integration of sine? 2 Vm upon t. Integration of sine is minus cos, and therefore minus cos omega t divided by additional term, again as differentiation, and it is divided. Limit is from 0 to t by 2. Okay, now I can write this omega outside, or yes, also minus sign I can write outside. That is equal to this minus 2 Vm upon omega t. In bracket, now we have to put limit. Okay, that is cos. I can write omega means 2 pi upon t. And here it is t by 2. Minus, if you put t is equal to 0, then yes, it will become obviously cos 0. Simple. So yes, this t cut, 2 cut, and this 2 cut. I can also write this omega as here is. See, here is equal to minus 2 Vm upon omega means 2 pi upon t into t. In bracket, cos pi means minus 1, minus cos 0 means 1. Clear? So this t cut, 2 cut, minus 1, minus 1, minus 2, and here it is minus Vm upon pi. So obviously average is equal to, it is 2 Vm upon pi. It is 2 Vm upon pi. So yes, on the mathematical steps, how to find average, you have to remember this equation, how to find average of given function. Clear about this? Yes, you may find its average over a period, over a complete period, it will be 0. Yes, you know that, it will be 0. Okay, now we will see what is next question. See, here it is. The value of AC voltage of generator is V is equal to 0 at time t is equal to 0. At time t is equal to 1 upon 100 pi second, the voltage is 2 volt. The voltage keeps on increasing up to 100 volt. Determine frequency of voltage source. See, first of all, the value of AC voltage of generator is V is equal to 0 at time t is equal to 0. From this statement, we can say that voltage is function of which trigonometric function? Okay, voltage is function of trigonometric which cos or sine. Yes, see here, if you take yes, V is equal to, it is Vm cos omega t, or we have another option, that is let V is equal to Vm cos omega t, or V is equal to Vm sin omega t. Out of these two voltage, which equation we have to use in this equation? It depends on this condition. Okay, at time t is equal to 0, voltage is 0, which is possible only in this, not in this. So obviously we have to use this equation. Okay, now at time t is equal to 1 upon 100 pi second, the voltage is 2 volt. Means whenever V is equal to 2 volt, tan T is equal to 1 upon 100 pi. Okay. The voltage keeps on increasing up to 100 watt. Means it is its maximum value. So it is Vm. So Vm is equal to, it is 100 watt. So simple. You have to put these three values in this above equation. So V is equal to 2 volt. Vm it is 100. Sine. Here it is omega t. Yes, omega means I can write it is 2 pi f. And it is 1 upon 100 pi. Simple. Okay. So if I take 100 this side, it will be 1 upon 50 is equal to, it is sine 2 pi cut. So it is obviously 1 upon 50. It is 1 upon. Now see, here it is. Now see, here it is. 1 upon 50. F upon 50. Okay, it is F upon 50. Clear about this? Now see what happens. Here it is. Here it is. Okay, sine F upon 50 is equal to 1 upon 50. If you take 1 upon 50, 1 upon 5, that is 0.2. 1 upon 50 is 0.0. So yes, this value of sine is very, very small. And we know that when value of sine is very, very small, okay, when value of sine is small, angle is also small. And see, from this equation it is clear, angle is F upon 50 is obviously small. And we know that in this case sine theta is nearly equal to, sine theta is nearly equal to theta. So yes, I can compare this equation directly, like 1 upon 50 is equal to this F upon 50. So 50 plus, so frequency is equal to, it is 1 hertz. Frequency it is 1 hertz. Clear about this? So yes, it is one question which is based on this. Yes, you have to remember which equation you have to use. The equation you have to use depends on this initial condition. Clear about this? So yes, two easy questions, but yes, you have to remember. Okay. Next question, see. AC current is given by I is equal to I1 sin omega t plus I2 cos omega t. Find RMS value of current. Yes, you have to find RMS value of current. What is meaning of R and S? Root mean square. Root mean square. So first of all, which process you have to do? Okay, obviously it is square. Root mean square. So it is root of mean of square. So first process is square. So here I is equal to given. I will take square of this. So yes, I square is equal to I1 square sin square omega t plus I2 square sin square omega t plus 2I1 I2 sin omega t cos omega t. Simple. Okay. Now we have to find its average. So yes, it is I square is equal to, it is average of I1 square sin square omega t plus average of I2 square. Yes, I2 it is cos. Okay, you have to tell me it is cos. It is cos square omega t. I2 square cos square omega t plus, see this equation, 2 sin theta cos theta means it is sin theta. So it is average of I1 I2 sin 2 omega t. Clear about this? So it is average. And now we know that, okay, in very first lecture of this chapter we have discussed, okay, average of sine or cos over a period is 0, but average of sine square or cos square over a period is 1 by 2. So I will write its direct answer, that is I1 square by 2 plus, here it is I2 square by 2 plus, as it is function of sine, its average will be 0. Okay, so yes, what is mean? It is I square is equal to under I square. Yes, I can also write this. Mean of I square is I1 square plus I2 square divided by 2. Now last step, that you have to make it square root, under root. It is I square is equal to, here it is I1 square plus I2 square divided by 2. And see, now it is called root mean square. Root of mean of square. So it is I RMS. Yes, it is I RMS. So I RMS is equal to, it is under root I1 square plus I2 square divided by, yes, it is divided by, clear about this? Okay, so yes, it is I RMS is equal to under root I1 square plus I2 square divided by 2. One easy question, but if you remember, okay, average of sine and cos over period is 0, while average of sine square or cos square over period is 1 by 2 if they are function of time. If they are function of time. Okay. Now next question. See, you are given one circuit. You are given one circuit. Impedance in given circuit you have to find. Okay, what is impedance in given circuit? See what is given. Actually it is inductor having inductive reactance 30 ohm. Capacitor having capacitive reactance 20 ohm. With voltage supply 90 volt, and yes, this inductor and capacitor, they are connected in parallel. They are connected in parallel. So yes, first of all, see, if total current flowing from circuit is I, so in this inductor current flowing is IL, in this current flowing is IC. As they are in parallel connection, in parallel connection, V is equal to 90 volt is same. V is equal to 90 volt is same. Yes or no? So yes, I will find first of all IL. IL is equal to, it is V upon XL. V 90, XL, yes, it is 30. So 0 0, it is 3. Simple. It is 3 ampere. Then I will find IC, that is V upon XC is equal to V, that is 90 volt, and here it is 20. So it is 4.5 ampere. But now what is relation between these two currents, IL and IC? Hello. Yes, you cannot apply. It's an I is equal to, it is IL plus IC. No, you cannot apply. Again, listen. You may say, sir, apply Kirchhoff's rule. That means I is equal to IL plus IC. I is equal to IL plus IC. That is wrong. That is wrong. Why? Because we have to first of all see, okay, if their phasors are in same direction or not. See, V is same. So let it is phasor of V. Let it is phasor of V. Now we know that in case of inductor, current lags behind the voltage by phase pi by 2. Yes, current lags behind voltage by phase pi by 2 in inductor. So yes, IL, it is in this direction. It lags behind voltage by phase pi by 2. While in case of capacitor, current leads voltage by phase pi by 2. So yes, it is phasor of IC. It is phasor of IC. Clear about this? So yes, see, from figure it is clear. Okay, IL and IC, their phasor, they are in opposite direction. They are in opposite direction. So we cannot add them. So what is, so therefore, what is resultant current? So therefore, resultant current I is equal to, it is, which one is IL and IC? So it is IC is greater than IL. So I can say it is IC minus IL. Yes or no? So yes, IC minus IL, 3.5 minus 3. Sorry, 4.5 minus 3. So it is 1.5 ampere. So that is total current supplied by this voltage source. Okay. Now we know that I is equal to, it is V upon Z. So Z is equal to, it is V upon I. What is V? 90. What is Z? Yes. Sorry. What is I? It is 1.5. It is 1.5. So yes, is equal to, it is 90. 1.5 means 15 into 10. 15 into 6. So it is 60 ohm. It is 60 ohm. Impedance of circuit is 60 ohm. Impedance of circuit is 60 ohm. Clear about this? Again, remember, in case of AC circuit, you cannot use directly this relation, that is I is equal to IL plus IC from figure. Okay? Because in AC circuit, it depends on phasor. Clear about this? Okay? So now you have to take care about this. Now next question. See, what is next question? See, next question is, in AC circuit, NR voltage applied is 220 volt. Okay, If potential difference across two ends of inductor is 176 volt, then potential difference across two ends of resistor. See, you are given like this. If it is inductor and resistor, if resistor, it is V, it is V, it is R, it is L. Now what is given? In AC circuit, LR voltage applied is 220 volt, means it is 220 volt. Okay. Potential difference across two ends of inductor, VL, and that VL is equal to, it is 176 voltage. Then your question is, what is potential difference across two ends of resistor? VR is equal to what? Again, hello, listen, again, you cannot use this relation. Okay, V is equal to, it is VL plus VR. You cannot use this relation, because when you are dealing with AC currents, AC voltage, you have to consider their phase. You have to consider their phase. Clear about this? Yes, you have to consider their phase. And see, if L and R, they are in series connection. So in series connection, we know that current I is same. So let phasor of current, it is in this direction. Now we know that it is phasor of current. Now we know that, okay, for resistor, phasor of I and V, they are in same direction. So let it is phasor of VR. In case of inductor, current lags behind voltage by phase pi by 2. Yes, current lags behind voltage by phase pi by 2. So obviously VL, it will be in this direction. So see, this VR and VL, they are not in same direction. VR and VL, they are not in same direction. So we cannot use this equation. Instead, we have to use this equation. According to law of parallelogram, the resultant V, how to write? Yes, V is equal to, it is under root VL square plus VR square. VL square plus VR square. So yes, therefore V square is equal to, it is VL square plus VR square. So therefore VR is equal to under root V square minus VL square. From this equation now you can find what is potential difference between two ends of resistor. Clear? So see, this difference between AC and DC. DC in previous chapter number 1, 2, 3, 4, 5 and 6. We have discussed about DC sources. Okay, battery, we have used battery. It is not battery, it is AC voltage, it is AC voltage. Clear? So you have to take care about this. Okay, whenever you are dealing with AC, see, you cannot add current directly, you cannot add voltage directly. You have to consider their phase. And from that phase, you can write equations. Clear about this? So yes, it is difference between AC and DC that you have to understand and how to solve such questions. Okay? Otherwise, yes, you will be given this direct answer. Okay, if V is equal to VL plus VR, then make VR a subject, then VR is equal to V minus VR, then 220 minus 176. Option will be available. Yes, option will be available. In this case also, option will be available. Okay, according to DC, you have to consider this cases. Clear? Okay, so there are some extra questions for you to understand or to clear your concept. Next question, see, question is, what is reading of voltmeter and ammeter in this figure? What is reading of voltmeter and ammeter in this figure? See, here you are given AC voltage source, V is equal to 240 volt, resistance R is equal to 30 ohm, XL 25 ohm, XL 25 ohm. So yes, here, as XL is equal to XC. It is resonance. Okay, and as XL is equal to XC, here VL is equal to VC, and we know that VL and VC, their phasor, they are in opposite direction. Okay, VL and VC, their phasor, they are in opposite direction. Okay, so yes, their resultant will be 0. The resultant will be 0. Okay, therefore, voltmeter, reading of voltmeter is 0. Why 0? Again, why 0? Because XL is equal to XC. In series connection, current is same. So yes, VL is also equal to VC. But if we draw Phasor diagram, then you know that Phasor diagram. In case of series connection, current is same. Okay, for Phasor of resistor, it is obviously in this direction. Okay, in case of inductor, current lags behind voltage by phase pi by 2. Current lags behind means it is VL. So obviously VC will be in downward direction. See, VL and VC are in opposite direction. So yes, the resultant will be 0. The resultant will be 0. Okay, so reading of voltmeter is 0. Next question is, what is reading of ammeter? As it is resonance, we know that in case of resonance, at resonance, we know that Z is equal to, that is impedance, it is 20 R, and therefore I is equal to, it is V upon R. What is value of V? It is 240 volt. What is value of R? It is 30 ohm. 0 cut, so it is 8 ampere. So value of reading of ammeter is 8 ampere and reading of voltmeter is 0 volt. Clear? So yes, there are some extra questions for you. This is it for today.